Hey guys, welcome to 6.2. Here we're going to get into the 6 trigonometric functions and also introduce the unit circle. I'm going to make a separate optional video on filling out the unit circle in case anybody didn't remember how to do that. But just a reminder, the angles are in degrees and radians written out, and all of the coordinates, all of the ordered pairs, x comma y, are always cosine comma sine. Okay, so the x value is cosine and the y value is sine. Now, while we're at it here, let's do something. I'm going to draw a quick triangle. If you don't like the unit circle, you can also think of these all as triangles. So for example, let's say that this one was, well, it's not drawn great, but let's say this was a 30-degree triangle here. So let's say it was this guy right here. Okay, so the cosine value is the x, right? So root 3 over 2. And the sine value is the y, so the 1/2. How would you guys get tangent? Isn't, you know SOHCAHTOA, isn't tan just opposite over adjacent? Right? So O over A. So for all of these problems, if it ever asks for tan, just do y over x. So sine over cosine, because that's TOA. All right, let's do some. So flip it over. Find the exact values of each expression. You can use the unit circle, or you can use your triangles, or whatever memory you have to do these problems. So sine of 45, if you guys look at the unit circle, I'll pull it out here. So sine of 45 is root 2 over 2. All right, so let's write that down. And then times cosine of 180. Cosine is x, so it's negative 1. So they just want you guys to solve what's root 2 over 2 times negative 1, and that would just be negative root 2 over 2. So that's the answer for the first one. No decimal, we want exact answers only. Okay, tan of pi over 4. So let's go to pi over 4. Remember, tan we said was sine over cosine, y over x, opposite over adjacent. So what's root 2 over 2 divided by root 2 over 2? Well, that's just 1. Okay, and then minus sine of 3 pi over 2. So 3 pi over 2 is down here. Sine is the y, so negative 1. Okay, so what's 1 minus negative 1? Well, it becomes plus a plus, so the second answer is 2. Okay, secant of pi over 4. Now, secant is the reciprocal of cosine. Okay, so let's find cosine of pi over 4. And that's right here at root 2 over 2. We are going to flip it, take its reciprocal. So instead of root 2 over 2, we're going to call it 2 over root 2. Okay, and we want to square that. So it's the reciprocal of cosine, plus. Now cosecant is the reciprocal of sine. So let's go up to pi over 2 and find sine. And that's again the y value, that's 1. Oh, we have to flip it, sorry. The reciprocal of 1 though is still 1, so we're okay. All right, if you guys solve this, 2 over root 2 squared, you can use a calculator, do in your head. What's that? 4 over 2 is just 2. So then 2 plus 1 is 3. This one ends up being 3. Okay, example 2. Just kind of going over what all these trig functions are. So pi over 3 we know is 60 degrees. Let's find all 6 trig functions at pi over 3. Okay, so here's pi over 3, right? Okay, we definitely have cosine and sine, so that's easy. maybe I can fold this so you guys can, we don't have to keep switching back and forth. Okay, I don't know if that helps. All right, so at pi over 3, this is cosine and this is sine. All right, so sine is root 3 over 2, cosine is 1/2, right? Remember we said tan is sine divided by cosine. So we kind of have to do a little bit of work. Root 3 over 2 divided by 1/2, but dividing is like multiplying by the reciprocal. So now it's really like root 3 over 2 times 2 over 1, but that's nice because these cancel. So tan of pi over 3 is just root 3. And then once you find the first original 3, then these are all just their reciprocals. So cotangent is the reciprocal of tan. So not root 3 over 1, but 1 over root 3. And we always want to rationalize our answers. If you rationalize 1 over root 3, you end up getting root 3 over 3. I would prefer your answer rationalized. This isn't wrong, it's just bad form. Now, secant is the reciprocal of cosine. So the reciprocal of 1/2 is 2. And then new color, running out of colors. Cosecant is the reciprocal of sine. So not root 3 over 2, but 2 over root 3. And if you rationalize that, we don't want a root in the denominator. It's 2 root 3 over 3. Okay, awesome. These are more just reading the unit circle, so we can skip those. All right, moving on. Use a calculator to find the approximate value of each. Okay, so now you guys have to take out your calculators. And, well, here, do you guys want to do these real quick? We'll just run through them here. So cosine of 5 pi over 4. 5 pi over 4 is here, and cosine is the x value. So negative root 2 over 2. Sine of 135 is up here, and that's root 2 over 2. Tan of 315 is over here, but if you divide sine by cosine, you end up getting negative 1. Now sine of negative pi over 4. So if positive pi over 4 is up here, then negative pi over 4 is going clockwise. And sine there is negative root 2 over 2. And then cosine of 11 pi over 4. So this one's a little bit harder. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4. 11 pi over 4 is actually right here. And if they want cosine, that's the x value. So negative root 2 over 2. Okay, on to the calculator ones. Now, something to be aware of is changing your mode depending on if it's in degrees or radians. So this one's in degrees, so you want to go to mode and make sure your calculator, you hit enter on degrees, and then you can clear it. And then it's as easy as just typing it in. Cos 48, enter. So this is 0.669. I'm just going to do 3 decimals. Okay, now cosecant is the reciprocal of sine. So it's 1 divided by sine of 21 degrees. All right, if you hit enter, that's 2.79. One thing to note, it's not inverse. It's reciprocal. There's a difference. Now look at letter C. This is in radian form. So we want to go to mode and make sure we're in radian mode. Okay, then hit clear, and now we can type this in. Tan of pi over 12. And as a decimal, that's 0.268, we'll call it. Done. All right, last one. What if they give you guys an ordered pair that is on the terminal side of the angle, and they want all 6 trig ratios at that angle? So let's do a little sketch here. Let's see where 4 comma negative 3 is. So right 4, down 3. And let's make a triangle where the reference angle is coming from the origin and the right angle is coming off of the x-axis. You always want your right angle coming off of the x, not the y. Okay, so let's call this angle theta. All right, so what do we know? We know that the x value is 4 and the y value is negative 3. They want to find all 6 trig functions. So let's start by doing Pythagorean theorem to get this side here. So a squared plus b squared equals c squared. It's a 3, 4, 5 triangle, right? So we know that that's 5. Okay, so this is going to be a lot of work. They want the sine ratio, the cosine ratio, the tan ratio, and then they want the reciprocals, the cosecant, the secant, and the cotangent. They want all 6. Okay, so this is just basic SOHCAHTOA. So sine is O over H, so negative 3/5. Cosine is A over H, so 4/5. And tan is O over A, so negative 3/4. And then these are just the reciprocals of their buddies. The reciprocal of cosecant is sine, so negative 5/3. The reciprocal of secant is cosine, so 5/4. And the reciprocal of cotangent is tangent, so negative 4/3. And that's all you guys have to do. Okay, thank you for watching the unit circle and the 6 trig ratios.